So dear students, welcome to the one-shot series of Industrial Engineering. This is lecture number 2 on Simplex method. Generally, if you see the competitive examination scenario, many teachers, they do not cover Simplex properly because they tell actually that such long problems will not come in GATE. But that is wrong. You see GATE papers. Sometimes the intermediate stages of Simplex table are being asked in exam. And in fact, based on those questions, in our PW test series, I have designed very beautiful problems based on Simplex. In GATE, these problems comes. Maybe quite possible teacher may not know. There's a reason he doesn't teach. But it's a very much GATE syllabus. It is mentioned. And see our PW test series. I have designed very beautiful problem. Our team, we have a P&I, we have 4 people, 1 SME and 3 teachers. We have designed very good problems. So Simplex method, this is our team. So PW is not a work of, single person. We have a team expert in practically every field. So what are the topics that I am going to cover in the Simplex analysis? First of all, introduction. Means what are the basic procedures of Simplex? Then Big M method. When we have to apply Big M method. Like in the graphical method, we have seen that certain linear programming problems may have alternate solutions. So how to see those things on a Simplex, alternate solutions? Now, what is degeneracy in Simplex? That I am going to discuss. And at last, sensitivity analysis. So these things I am going to cover with the help of questions. I will be discussing number of questions. See, because it's a crash course type of thing in English, one-shot series is a crash type of course in English. So I will not repeat the question. I will discuss only the variety. Okay, na? In our full course, we are going to discuss a lot. All right. And this is my credential. I'm gold medalist in BTech from AMU because I was a university topper. I'm MTech on PhD from IIT Delhi. And between MTech and PhD, I worked for engineering services, IES, for approximately 1.5 years. And I'm a researcher in production. And as per Scuba's data, I'm top 5% researcher in the world for year 2020. So let us begin our discussion on Simplex. Let us see the first problem. Okay. So here there are 3 variables directly, because it's a one-shot series, we don't want to waste time. But if there is any question, please direct them to me. Now there are 3 variables, x1, x2 and x3, and there are 3 constants. First constant, second constant, third constant. And this is a very important constant, x1, x2, x3 greater than equal to 0. It's a very important constant. I also told you during graphical method, because that decides that my solution lies in which quadrant. My solution lies in which quadrant, it decides that. If you, by God's grace, you may join IIT after cracking GATE. And if you choose industrial engineering as an MTech discipline, you will make programs, because we are studying Simplex method only to crack GATE exam, Great Engineering Services and other competitive examination. But if you are studying MTech industrial engineering, there will be 20 variable, 30 variable. In a typical industrial scenario, there will be 20, 30 or sometimes 50 variables. So naturally, those problems you cannot solve manually. So you have to make a program. Programming for Simplex, programming for transportation. Okay? And if you know how to make the programs for these things, such people will be highest paid in industry, share market, banking sector. These problems are basically implemented practically, and if you know how to make the programs for these things, such people are highest paid. So I'm just giving the introduction, but unfortunately in most of the private colleges and most of the coaching institutes, they do not cover Simplex properly. Okay, all right. So now how to begin the solution? These constraints, we have to make the equality sign. On the left hand side, because it is less than equality sign, left hand side something is less. So if I add one variable to x1 minus x3 plus s1, add some variable on the left hand side so that it becomes equal. This s1 is called slack variable. S1 is called slack variable. See, I will be introducing terms one by one, not all the terms at a time. So this is the first constraint, second constraint, third constraint. Second constraint also left hand side is slightly less. So to make it equal, add another slack variable here. So x1 plus x2 minus x3 plus s2 is equals to 10. That is the second constraint. Okay. Third constraint also left hand side is slightly less. Make it equal by adding another slack variable on the left hand side. So 2x1 minus 2x2 plus 3x3 plus s3 is equals to 0. That is the third constraint. Okay, all right. Now x1, x2, x3 are there in the objective function. I have introduced slack variables s1, s2, s3. s1, s2, s3 are called slack variable. s1, s2, s3 are called slack variable. So slack variable coefficients in the objective function, slack variables coefficient in the objective function will be 0. So our objective function is a maximum z is equals to x1 minus x2 plus 3x3 plus 0s1 plus 0s2 plus 0s3. Their coefficients in the objective function will be 0. Both slack or surplus variable I will tell you after half an hour. Both slack and surplus variable coefficients in the objective function will be 0. Always remember one thing. Always remember one thing. Simplex problem, I hope all of you are sitting with pen and paper, because one shot series doesn't mean that it's like a movie that you are seeing movie 4 hours are passed, then go. No, you have to sit with the pen and paper and go with me. Simplex method means it's a profit maximization. It's a profit maximization. Simplex problems are solved for profit maximization. You know what is the meaning? To begin our iterations, my objective function should be that of maximization. To begin my iterations, my objective function should be that of maximization. But suppose minimization function is given to you. Suppose minimization function is given to you. That function we have to convert into maximization before solving. Simplex problems are meant for profit maximization. But suppose minimization objective function is given to you. To begin the iteration, we have to convert the objective function to that of maximization. How to do it, I will tell you in the next problem. Okay? So now, how many number of variables in the objective function? Number of variables in the objective function are 6. x1, x2, x3, s1, s2, s3. There are 6 variables in the objective function. Now, we will prepare a matrix. Okay, because the reason I am going a little slow, because it is a recorded class, it is not live class. If it is a live class, I could have taken care of whatever doubts you are having. Because it's a recorded class, so I want to make sure that you don't get tense. But anyway, even if you have some difficulty, direct all the questions to me. All right? So now let us make a table. Let us make a table. Table number 1. Table number 1. So write all the variables in the objective function: x1, x2, x3, s1, s2, s3, and b. B is the right hand side. Now, see the coefficients of these variables in the objective function. x1 is 1, x2 is -1, x3 is 3, s1 is 0, s2 is 0, s3 is 0. So their coefficient 1 minus 1, 1, 3. So their coefficient right at the top, and this row is called Cj row. This row is called Cj row. Okay. Now, first line will be the coefficient of first constraint. Second line will be the coefficients of the second constraint, and so on. First constraint, 2, x2 is 0 because x1, x3, x2 is 0. So x1 is 2. There is no x2 here. So it means coefficient of x2 0. Correct? Understanding, na? Now x3 coefficient is -1. x3 coefficient is -1. S1 coefficient is 1. There is no S2, S3, and the right hand side is 2. So I have written 2. So I have written the information of the first constraint. Information of the first constraint. Now write down the information of the second constraint. So 1, 1, -1. 1, 1 -1, 0, 1, 0. 1, 1 -1, 0, and right hand side is 10. It must have been there in your notes because I told you to copy as the class is going on. Now the information about the third constraint, 2 - 2, 3. 2 - 2, 3, 0, 0, 1, and right hand side is 0. I hope that is correct. Okay. I hope that is correct for all of you. Now here, this row is a Cj row, and I am writing some variable, and those variables are called bases. Bases. You know, what is the meaning of bases? What is the meaning of bases? I am giving initial feasible solution to the problem. I am assigning some solution to the problem. Always remember, initially slack variables enters into the basis. So in the first constraint, what is the slack variable? S1. So that will first enter into the basis. Now in the second constraint, S2 is the variable, so S2 will enter into the basis. And in the third constraint, S3 will enter into the basis. Bases are basically the initial solutions. Are the initial solutions. It's our initial matrix, and initially slack variables enters into the basis. By God, I'm telling you, if it is live class, we would have enjoyed like anything. Okay, na? We would have enjoyed like anything this one. Okay. Now, the coefficients of these variables in the objective function right on the left hand side. Coefficient of S1 is 0. Coefficient of S2 is also 0. And coefficient of S3 is also 0. Correct, na? At any stage of simplex table, coefficients of these variables in the objective function are written on the left hand side. Coefficient in the objective function written in the left hand side. Okay. Now, see, this is the C0. Now, there is something called E0. You know what is 𝐂0? What is 𝐂0? Look at the board carefully. This into this plus this into this plus this into this. Write it here. Because everything is 0, so it will be 0. This into this plus this into this plus this into this. Write it here, okay? Now this into this plus this into this plus this into this. Write it here. Because all these values are 0, so you will get 0 everywhere. You will get 0 everywhere in the row. Now we calculate 𝐸𝐽 minus 𝐸0. We calculate 𝐸𝐽 minus 𝐸𝐽. We calculate 𝐸𝐽 minus 𝐸𝐽. So 𝐸𝐽 minus 𝐸𝐽 is this row minus this row. So 0 minus 1 is minus 1. 0 minus minus 1 is plus 1. Minus 3, 0, 0. 𝐸𝐽 minus 𝐸𝐽. What these variables indicates to you? What these variables indicates to you? Simplex procedures are for profit maximization. Once again, I would like to tell you one more thing, that there are some books, you have to hear very, very carefully. You have to hear very, very carefully. Simplex method, there are a lot of confusion, because many private colleges, they don't teach properly, and even coaching setup, nobody teaches. Hardly anybody teaches properly the Simplex. And when the question comes, a teacher will declare that it is out of syllabus and get away with it. Students do not question the teacher. I don't know why. Hear carefully what I am saying. In some books, this is 𝐶𝐽 minus 𝐸𝐽. There is no problem, because our concept will be reversed. But I am following the procedure given by Taha, and he uses 𝐸𝐽 minus 𝐸𝐽. You know why he uses 𝐸𝐽 minus 𝐸𝐽? Because iterations of dual simplex will be easier. What is dual simplex? I will tell you, and when we have to use dual simplex, that also I will tell you. Okay, na? So those iterations will be easier if you follow 𝐸𝐽 minus 𝐸𝐽 route. So 𝐸𝐽 minus 𝐸𝐽, 𝐶𝐽 minus 𝐸𝐽. Our concept will be reversed, but better to follow 𝐸𝐽 minus 𝐸𝐽. Okay, na? Because IIT's Taha is the book that is followed. Hamdi A. Taha. What these variables indicates to you? Simplex procedures are meant for profit maximization. And in the differential equation, you are saying d2 by dx square is equals to negative, then it's a maximum function. It's a maximum function. So it's exactly the same concept. What is the meaning of this? Minus 1. What is the meaning of minus 1? Please hear carefully, because in GATE, some question may pop up GATE or some other exam, because this, you know, I'm recording this industrial lectures primarily for GATE, but it is meant for all the competitive examination, short notes for all the competitive examination. You know, what this -1 indicates? What this -1 indicates? Very, very carefully you should hear. If you take decision on x1, if you take decision on variable x1, there will be unit increase in profit. There will be unit increase in profit. d2 by dx square should be negative for maximum function. Now this +1, unit loss. If you take decision on variable x2, there is a unit loss. -3 means if you take decision on x3, there is a 3 unit profit. If you take 1 unit of x3 decision, there will be 3 unit profit. So I would like to maximize my profit in the simplex. I would like to maximize my profit in the simplex. So you know what I will choose? What I will choose? I will choose the maximum negative from ej minus e0. I will choose the maximum negative from ej minus e0. Now understood why I am choosing the maximum negative from ej minus e0? Understood now? So now this is the entering column. This is the entering column. This is the entering column. I hope all of you are doing well. Once again in GATE, nobody will ask you to solve complete problem, but you should know all the intermediate steps. Then you calculate a theta column. You calculate theta column. Theta column is nothing but matrix B divided by entering column. Matrix B divided by entering column, meaning 2 divided by -1 is -2. 10 divided by -1 is -10. 0 divided by 3 is 0. So theta is a B divided by the entering column. We select the maximum negative from ej minus from the bottom, and we select minimum positive including 0. Minimum positive including 0 from theta column. We select minimum positive value including 0 from this column. Now some of you may ask, sir, what is the ej minus e0 tells you the unit increase or in profit or unit loss by taking decision on that variable. What does this indicate? What does this indicates? It indicates resource idleness. Because these these constraints are resources only, na? These constraints are resources only. So in the optimum condition, I want minimum idleness. I want minimum idleness. So I will select this one. Okay. So this is your entering column. Entering column. Intersection of column and row. Intersection of column and row. That value is called pivotal value. That value is called pivotal value. Pivotal value. In the normal simplex procedure, pivotal value should be positive. Normal simplex procedure, pivotal value should be positive. It cannot be negative. Pivotal value should be positive. So you know what is my decision here? What is my decision here? My decision is S3 will leave the basis in place of that X3 will enter into the basis. S3 will leave the basis and in place of that X3 will enter into the basis. That is my decision, very, very important decision. So this is your table number 1. See, I am teaching you, so it is taking time. But once you learn the procedure, and when you are all alone with your questions, it will be very fast. So table 1, what is my decision? S3 is leaving the basis, and in place of that, X3 is entering to the basis. X3 is entering into the basis. Okay. Correct. So this is my first table. You will get the printout, so don't worry about these things, okay, na? Table 2. So what was the decision on my first table? S3 is leaving the basis and X3 is entering into the basis. So again make the table X1. Shall we increase the thickness little bit? Good. X1, X2, X3, S1, S2, S3, B. So what is my decision? S1, S2, X3. See, in place of S3, I have put the X3 now. Okay. Objective function will remain as it is. 1, -1, 3, 0, 0, 0. So objective function is going to remain same. Now what we have to do, we have to have a cool head. While doing the iterations of the simplex, your head should be cool. Your head should be cool. What do you have to do? Make pivotal value equal to 1. Make pivotal value equal to 1. So what you do? Divide the entire row by 3. So the pivotal value will be equal to 1. Divide the entire row by 3. So 2 by 3 minus 2 by 3, 1. We have to make the pivotal value 1. 0, 0, 1 by 3 and 0. So whatever row operations you are doing, you have to do in the B matrix also. Whatever row operations you are doing, you have to do in the B matrix also. So make the pivotal value equal to 1. Second thing you have to do is, wherever is the pivotal value, so above the pivotal value and below the pivotal value, here very carefully, above the pivotal value and below the pivotal value, make the value 0 only by row operations. Like in the matrix, na? It's a matrix. In simplex, we do only row operations. We do not do column operations. So make value zeros only by row operation. Only by row operation. So first row, here it's a -1. So R1 new will be R1 old plus R3 new. This is already 1 here in a new row. Okay, na? This old row, if I add up with the new row, this value will become 0. Because my target is to make all the values above or below 0. So each row operation, we take the old row, and the new row, we add or subtract the new row. We multiply or divide the new row, not the old rows. Okay, na? So if I do this operation, this value will be 0. Now 2 plus 2 by 3. So it's a 8 by 3. Correct, na? 2 plus 2 by 3 is 8 by 3. 0 plus minus 2 by 3 is minus 2 by 3. 1 plus 0 is 1. 0 plus 0, 0. 0 plus 1 by 3 is 1 by 3. 2 plus 0 is 2. We do only by only row operation. So this is 0. Now make this also 0. Here also minus 1. So R2 new will be R2 old plus R3 new, because this is also minus 1. Okay. So now let us do it again. Please do that. 1 plus 2 by 3 is 5 by 3. 1 minus 2 by 3 is 1 by 3. 0. 0 plus 0 is 0. 1 plus 0 is 1. 0 plus 1 by 3 is 1 by 3. 10 plus 0 is 10. Everybody's okay? Everybody's okay? Match? I'm basically waiting for some time. Just check. Okay. Again repeat the same procedure. Again repeat the same procedure. The way we did before. This is the basis now. Coefficient of these variables in the objective function: S1 0, S2 0, X3 is 3. EJ. EJ. This into this plus this into this plus this into this, write it here. 3, 2, correct now? Minus 2, 3, 0, 0, 1. EJ minus EJ. 2 minus 1 is 1. Minus 2 minus 1 is minus 1. 0, 0, 0, 1. Correct? So now we have to select the maximum negative. Maximum negative here. So this is your entering column. Calculate theta. Out of these three, only this is the positive value, na? Of course, you can calculate theta also, but pivotal value cannot be negative for normal simplex. Pivotal value cannot be negative for normal simplex, so this will be the row, and this is the pivotal value. This is the pivotal value. Okay? Now make the next table now. Table 3. table 3. So what is my decision? What is my decision from here? S2 will leave the basis and X2 will enter. That's the decision, na? S2 will leave the basis and X2 will enter. So X1, X2, X3, S1, S2, and the B, S1, X2, X3, because X3 is already there. Now X2 leaves the basis, in place of that X2 comes. Okay, 1 minus 1 3, 1 minus 1 3, 0 0 0. Okay, again we will do the same thing. Again we will do the same thing, making the pivotal value equal to 1. Making the pivotal value equal to 1. So how to make the pivotal value equal to 1? Multiply by 3. Multiply the entire row by 3. So I have solved this thing, and in fact it is from my book. Five 1 0 0 3 1 and 30. It's my book basically. I have 3 books: one production, one industrial engineering, and third one is there is another book because it is not related to you. Now, because I have switched over to PW now, so Narosa is publishing these books, and my production book, it's a 4th edition production book, will be available at January end, and industrial engineering book will be available close to February mid. I'm writing with some IIT professors because I want to add some content in that. So whatever book I am having, because I'm taking problem from this my own book. So these books will be available again in the market. Okay, na? Narosa Publications. So now this was the pivotal value. Make all the values. What is my next step? Make all the values above and below 0. Above and below we have to make it 0. So this is minus 2 by 3. So R1 new is nothing but R1 old. How much is R1 old? Minus 2 by 3. And this is 1. So can I say plus 2 by 3 R2 new? 2 by 3. If I add, because it's minus 2 by 3, so it will become 0. This is also minus 2 by 3. So same operation I will do in the third row. R3 new plus 2 by 3 R2 new. So, we have to be very, very careful. These multiplication and divisions, na, I am doing only in the new row. I will not do in the old row. I will not do in the old row. So what will happen? These values will become 0. These values will become 0. So I am giving you 30-second pause. Can you get the complete matrix? Because industrial is nothing but practicing. Can you give me the complete matrix? So these things are just I'm writing 6, 4, check. Check, is that okay with everyone? The same thing you are getting? Same thing you are getting? So this is Cj, Ej. Coefficient of S1 is again 0. Coefficient of X2 is -1. Coefficient of X3 is 3. So 0 plus is 0 into 6 plus -1 into 5 plus this into this, write it here. 12 minus 5 is 7. Correct, na? -1, 3, 0, 3 and 2. Okay, and Ej minus Ej, 7 minus 1 is 6, 0, 0, 0, 3, 2. Okay, now here what I am able to see here, what I am able to see in the Ej minus Ej row, all positive. In Ej minus Ej row, all positive, it means it is an optimum matrix. It means it's an optimum matrix. No further iterations are required. It's an optimum matrix. No further iterations are required. Now we have to read the solution now. We have to read the solution. We have to compare the bases with B matrix. Basis with B matrix. So S1 is equals to 22, X2 is equals to 30, X3 is equals to 20. So S1 is equals to 22, X2 is equals to 30, X3 is equals to 20. whatever variables that are not present in the basis, their solution will be 0. Whatever variables that are not present in the basis, like x1, their solution will be 0 because they are non-basic variables. So maximum z will be 0 minus 30 plus 3 into 20. So 30 is the answer. So this is called normal simplex, and that's the procedure. So what I recommend to all of you, you may have to see this lecture more than one time to get the idea of the simplex. This is the next question. Of course, this particular question you can solve by using graphical method, but we are learning a concept. So this question I will answer using the simplex method because we would like to learn a concept with the help of this question. Now, what I told you, simplex procedures are for profit maximization. Simplex procedures are for profit maximization. But when the minimization function is given to you, we have to convert into a maxima function. To begin simplex procedure, normal simplex procedure, my objective function should be a maxima 1. So maximum z is nothing but, how to do it? Subtract by -1. So minus 4x1 minus x2, this becomes maxima. So loss becomes profit, profit becomes loss by adding a negative sign. Correct, na? That's the way we do it. Now, these are the constraints. The first constraint, left hand side, the value is slightly larger. So what I will do, I will subtract some variable s1 from the left hand side. 3x1 plus 4x2 minus s1 greater than equal to sign means, if I compare with graphical, region moving away from the origin, and it extends up to infinity. So there has to be some limit. For that, we use one artificial variable a1, let us say a. S1 is called surplus variable, and in the constraint, whenever surplus variable come, one artificial variable also comes to along with it. We have to put a limit on the feasible reason, okay? Otherwise, there are some details in it. Maybe in the regular classes we will, introduce them. Here our target is to somehow capsule course for GATE, okay? Na? So whenever a surplus variable come, one artificial variable will also come with it. artificial variable comes with that. Now see the what sentence I am speaking. Here very carefully what sentence I am speaking. Artificial variable incur heavy loss in the objective function. Artificial variable incurs heavy loss in the objective function. So you know how it will be? Plus 0 S1, surplus variable coefficient is 0, and minus M A1. A1 is an artificial variable. M is a very large number. Almost infinite. M is a very large number, almost infinite. Because of this procedure, whatever I am going to do, it is called big M method. Whatever procedure I am going to adopt, it is called big M method. So loss means negative sign. M value is very high and A is an artificial variable. So artificial variable incurs heavy loss in the objective function. Now understood? So whenever surplus variable come, along with that one artificial variable will always be there in that constraint. So plus A1 is equals to 20, that is your constraint 1. Now the second constant, left hand side is slightly less. So here we will add a slack variable. So x1 plus 5x2 plus s2 is equals to 15. And s2 is called slack variable. S1 is called surplus variable, A1 is called artificial variable, S2 is called slack variable. So I have introduced 3 terms. So I am gradually introducing the terms one by one, not everything at a time. So I told you, this problem we can solve with the help of graphical, but I want to do with the help of Simplex because I want to learn something. Correct, na? And anyway, I told you that this is a very important constraint. This tells you that my solution matrix is in the first quadrant. My solution matrix is in the first quadrant. So now, of course, the coefficient of slack variable will be 0 in the objective function. Okay. Let us again make the table. Based on this information. So how many variables are there? X1, X2, S1, A1 and S2. Table number 1. Objective function x1, x2, s1, a1, s2, b. Correct, na? C0 is the coefficient of these variables in the objective function. -4 -1 -4 -1 0 -m 0. Correct, na? Now write the information about the first constraint. 3 4 -1 1 3 4 -1 1 0 and 20. That's what we have learned in the simplex, huh? And the second one is 1 5 S2 is 1 1 5 S2 is 1 and the right hand side is a 15. Okay. Once again, another funda once again. In the second constraint, there is a slack variable, na? S2, so that S2 will enter into the basis. S2 is appearing in the second constraint. So that will appear into the basis first. Now in the first constraint, there is a surplus variable and there is an artificial variable. There is a surplus variable and there is an artificial variable. If artificial variable is there in the basis, if artificial variable is there in the constraint, that will first enter into the basis. In any constraint, if there is an artificial variable, that will first enter into the basis. You know why? We want to get rid of artificial variable as soon as possible. We have to be very, very careful. Each example, I am giving you some funda. I am dead slow repeating sentences because it's a recorded one. That is the reason I am putting this much effort. Otherwise, if it's a live, then we would have dealt with it differently. Why the artificial variable first enter into the basis? Because I want to get rid of artificial variable as soon as possible. It is an undesirable element. Okay. Now, coefficient of artificial variable in the objective function is -m and S2 is 0. Calculate EJ. EJ is same thing, this into this plus this into this right here. So -3m -4m m -m 0. Correct, na? Correct? Next is EJ minus EJ. -3m plus 4 -4m plus 1 m 0 0. So what our procedure tells you, I will take the maximum negative from this. Value of m is very high. Value of m is very high. This is the maximum negative, and this is your entering column. As I told you some time back, you may have to see the Simplex lecture one more time, because in private colleges we do not study Simplex properly. Okay, and even in the coaching setup also, some of our teachers also, they don't teach properly. I don't know why. Entering column. Theta. 20 divided by 4 is 5. 15 divided by 5 is 3. I will select the minimum positive. So this is my pivotal value. So what is the decision? Decision is S2 will leave the basis and in place of that X2 will come. S2 will leave the basis and in place of that X2 will come. Correct na? So let us make the next table. Table 2. X1, X2, S1, A1, S2, and then B. CJ here I will write the basis, and in the basis it was artificial variable and X2. Correct na? That was our decision that S2 is leaving the basis and in place of that X2 is coming. Now what was my next step? Making the pivotal value equal to 1. So how to do it? Divide the entire row by 5. In Simplex we do only the row operation, we do not do column operation. So divide by 5. So 1 by 5, 1, 0, 0, 1 by 5, 0, 0, 1 by 5, and 3. Now what was the next step? I have to make this value 0. Above and below the pivotal value we have to make 0. So how to make this 0? So R1 new will be nothing but R1 old. This is R1 old. And second row there is a 1. Minus 4 times R2 new, because the 4 has to be 0. At new place it is 1. So if you apply this operation in the first row, giving you 10 seconds, can you give me the answer? Can you give me the answer? Eleven 5 by 5 0. So entire row operation I have done this. Okay, once again I am repeating. Whatever multiple division I am doing, I do with the new row. I do not multiply anything in the old row. Subtraction, addition, whatever I do with the new row. So now this is my new table, and the coefficients are -4, -1, -4, -1, 0, -m, 0. Coefficient of A1 is -m, x2 is -1. EJ, this into this plus this into this, okay na? So -11/5m -1/5, correct na? -1 m 4m/5 -m -1/5. This is EJ. EJ minus EJ. This minus this. So -11/5m plus 4 na, plus 19/5, 0 m 4m/5 plus m 9/5m and minus m -1/5. M value is very high. M value is very high. So this is the maximum factor, and this is the entering column. The procedure remains same. The procedure remains same, whatever we are doing in every iterations. So now calculate theta column. 8 divided by 11/5. So 40/11. 3 divided by 1/5, so 15. This is the minimum positive. This is the entering row. And this is the pivotal value. This is the pivotal value. Now, another very, very important conclusion. All of you must hear, and that thing I will write it also down, because this sheet will be given to you as in the PDF form. So suppose if you miss hearing, you should read it. It's a very, very important statement. Our conclusion is A1 leaves the basis, and in place of that x1 appears. A1 leaves the basis, and in place of that x1 enter into the basis. I hope everybody is hearing patiently. In the while doing the simplex iterations, sometime it happens that one variable leaves the basis, and after few iterations, same variable again enter into the basis. It is possible. It is possible that some variable is leaving. After few iterations, the same variable again enters into the basis. Because we are talking about not a 2 or 3 variable problem, 50 to 60 variable problem. So it may happen, and there is no wrong with the solution. But once any artificial variable leaves the basis, it never re-enters again into the basis. Once any artificial variable leaves the basis, it never re-enters again into the basis. So what we can do, from our next iteration onwards, that column can be completely deleted. That column can be completely deleted from the next iteration onwards. If you maintain that column, it's a wrong matrix. So here, this I am writing here. Once artificial variable leaves the basis, it never re-enters again. It never re-enters again. Because a loop, sometimes a loop may also form. A leaving variable may again come back after some iterations, but artificial variable, it never happens. So now let us make the next table again with all these modifications. In the next table, we will not make this column. Okay, na? Once artificial variable leaves the basis, it never re-enters again. So x1, x2, s1, s2, and then b. I have not written artificial variable. So -4, -1, 0, 0. This is Cj. And now here will be the basis x1, x2. I have to make this pivotal value equal to 1. So how to do? Multiply the entire row by 5 by 11. Multiply the entire row by 5 by 11. So write down 1 minus 5 by 11 minus 4 by 11 and 40 by 11. What next we have to do? We have to make this 0. So only row operations. R2 new is equals to R2 old. This is 1 now in the next iteration. So minus 1 by 5 R1 new. That's the way we will do to make this 0. So use this operation in the new table and write all these parameters. If it is a live class, I would have waited for some time and expected some of your answers, then I would have given my answer. Again, but it's a recorded one. 1 by 11. And the right hand side is 25 by 11. Coefficients are -4, -1. You can first of all find out EJ, then EJ minus EJ. Just waiting for 15 seconds so that quickly you can do it. Calculation, you have to be very fast. Calculation in exam, you have to be very fast. And these things comes by practice. These things comes by practice. So 0, 0, 19 by 11 and 13 by 11. Because in EJ minus E0 all are positive, okay na? Because if we even keep on doing the iterations, still all the values are positive or 0. So this is the optimum matrix. Optimum matrix. Now let us read the solution. X1 is equals to 40 by 11. X2 is equals to 25 by 11. Now this values we can put it on the original objective function. Minimum z is nothing but 4x1 plus x2. So 4 into 40 by 11 plus 25 by 11. So that is our minimum objective function, 185 by 11. That is your answer. That is your answer. Correct? Everybody's okay? Sometimes I will be looking at the chat, because when this video go live, sometimes I will be not regularly, and if there is any question you can put in the chat also. But better Telegram channel. Telegram channel will be easy for me to handle, okay, na? Because regularly we are in contact. The next page will be better. One important funda. One important funda. In the constraint, whenever there is a less than equality sign, I am using slack variable. I am using slack variable while solving the simplex procedure. If there is a greater than equality sign, I am using two variables, surplus and artificial variable. Surplus and artificial variable. But suppose the sign is an equality sign. Sign is the equality sign. then I will not use slack or surplus variable. I will use only the artificial variable. No slack or surplus variable. No slack or surplus variable. Please remember that. If it is an equality sign, no slack or surplus variable, I will use only the artificial variable, and the coefficient of that artificial variable will be minus m in the objective function. So please remember these things. Please remember these things. Okay? Once again, I am taking certain selected questions from my industrial engineering book. I have written this book in 2016. Production book I have written in 2011. That was my first book. And I am, some of you may be knowing that book, production engineering book. Now there is a change in publisher, and January and Narosa. Production book he is taking first, industrial after 1 month. Question next. Next question. Here also we are going to learn a very important funda. Minimum z is equals to plus x2 is less than equal to 2, 3x1 plus 4x2 greater than equal to 12, x1, x2 greater than equal to 0. So the problem looks similar, but it is not similar. So my first constraint will be 2x1 plus x2 minus s1, sorry, plus s1 is equals to 2, slack variable. Here the surplus variable will come. Second constant, 3x1 plus 4x2 minus s2 plus a1 is equals to 12. Correct, na? Because surplus variable along with that one artificial variable will come. And the objective function will be, it's a minimum. Maximum z is equals to minus 3x1 minus 2x2 plus 0s1 plus 0s2 minus m a1. Till now it's everything is the same. Let us make the table. Based on this, I will use the next page table. x1, x2, s1, s2, a1, and then finally b. Objective function is minus 3 minus 2 0 0 minus m. Minus 3 minus 2 0 0 minus m. This is Cj. Now basis. First of all, write the information about the first constraint. 2 1 slack variable and 2 2 1 1 0 0 to check. It's the same thing, na? 2 1 1. This is 3 4 3 4 push. 0, minus 1, 1, and the right hand side is 12. Correct. In this constant, there is a slack variable, so there is no problem. Slack variable will first come to the basis. In the second constant, there is a surplus variable and there is an artificial variable. So artificial variable first come to the basis. Coefficient of artificial variable is minus m. S1 is 0. 𝐸𝐽 is minus 3m, minus 4m, 0, m, minus m. 𝐸𝐽 minus 𝐸𝐽, minus 3m plus 3, minus 4m plus 2, 0, m, 0. Correct, na? We have to select the maximum negative. This is the maximum negative, so this is the entering column. Theta 2 and 3. Minimum positive is 3. Theta means 2 divided by 1, 2. 12 divided by 4, 3. So this is the pivotal value. So what is your decision? Decision is S1 will leave the basis. In place of that, X2 will enter. S1 will leave the basis. In place of that, X2 will enter. Let us make the next table. Table 2. X1, X2, S1, S2, A1, B. Minus 3, minus 2, 0, 0, minus m, basis. So what was our decision before? In place of that, there is a X2. Pivotal value is already 1. So we don't have to do anything. Just write the equation as it is. 211002. 211002. But I have to make this value 0. How to do it? R2 new is nothing but R2 old minus 4 times R1 new, 4 times R1 new. Same procedure you can do and give me the second row. Just waiting so that you can. second row minus 5 0 minus 5 0 minus 4 minus 1 1 and 4. If you do that operation, it will be like this. Coefficient of A1 is minus m, x2 is minus 2. Again, ej minus ej. Giving 30-second pause in my recording so that you can calculate ej minus ej0. As I told you, in one shot series also you have to be with the pen and pencil. Calculate ej minus ej0. Five m minus 1 0 4m minus 2 4m minus 2 m this is my ej minus ej0 because we have practiced sufficient number of problems na. That's the reason. Now here there is a very important information that we have to extract. Very important information that we have to extract. Here all positive, so it's an optimum matrix. All positive, so it's an optimum matrix. Your optimum matrix has reached. Your optimum matrix has reached. But artificial variable your optimum matrix has reached, but the artificial variable is still there in the basis. Optimum matrix has reached, but artificial variable is still there in the basis. You know what such a situation indicates? There is no feasible solution. There is no feasible solution for this problem. There is no feasible solution for this problem. That's what it indicates. Like, it's a two-dimensional problem, na? If you graph like graphical we have done in the last lecture. First constant x1 by 1 plus x2 by 2 less than equal to 1. First constant. Second constant x1 divided by 4 plus x2 divided by 3 greater than equal to 1. So x1 is 4, this is 3. Region is away from the origin. Second constant. So there is no overlapping region. No overlapping region means no feasible solution. No feasible region or no solution. So in the simplex, it will appear like that. Whatever we have done, it will appear exactly like this. So this we have proven. For an infeasible solution, there is an optimum matrix, but artificial variable is still there in the basis. Because the problem was two-dimensional, so we could see. But suppose the variables are more than 2. It will not be possible for us to make the graph. It will not be possible for us to make the graph. But we should know how the infeasible problem looks like over the simplex. We should know that. Okay? Unfortunately, some people think that, you're teaching, especially post 2015, because I'm teaching this since year 2000. Post 2000, this coaching, GATE coaching became highly corrupted. Some teacher, because number of students were in, 10,000 plus. So coachings has to hire different teachers. And unfortunately, some teachers, those who are not qualified, somehow they are make the class entertaining, but they don't have stuff. So they percolated into the system. And they made a totally mesh out of it. This is not in the syllabus, as if they are making the paper. This is not in the syllabus. This is not in the syllabus. So I want to reinstate what I used to teach before. Because all of you, unless and until you raise the level, exam will not be cracked. There is something called feel good. And second thing is cracking exam. We are not here, especially in our GATE system, GATE Wallah. We are not here feel good. We are here to crack your exam. Of course, all our teachers teach in that way that you feel good, but not always. Okay? So now let us take the next funda. Maximum Z is equals to 6x1 plus 4x2 subjected to 2x1 plus 3x2 less than equal to 30, 3x1 plus 2x2 less than equal to 24, x1 plus x2 greater than equal to 3, and x1 x2 greater than equal to 0. Okay, na? Okay. Very easy. 2x1 plus 3x2 plus s1 is equals to 30 slack variable. There will be another slack variable here, 3x1 plus 2x2 plus s2 is equals to 24. Here there will be surplus variable minus s3 plus a1 is equals to 3, and the objective function is already maximum function. So maximum z is 6x1 plus 4x2 plus 0s1 plus 0s2 plus 0s3 minus m a1. Is that correct? So make the table. Make the table. x1, x2, s1, s2, s3, a1, b. Okay, na? Because again I have to flip the thing. So I am directly writing from here 6, 4, 0, 0, 0 minus m. First constant is 2, 3, 1, 0, 0, 0, 30. Second constant is 3, 2, 1, 3, 2, 0, 1, 0, 0, 24. Third constant is 1, 1, 0, 0, minus 1, 1, and 3. Okay, na? So I have written like this. Now this is Cj, and my basis will be in this direction. So S1, S2, and A1. 0, 0, minus m. So Ej will be minus m, 0, 0, m minus m. Minus m minus 6, minus m minus 4, 0, 0, m, 0. Maximum negative is here. This is the entering column. Pretty much same thing. Okay, pretty much same thing. Calculate theta. 15. 30 divided by 2 is 15. 24 divided by 3 is 8. 3 divided by 1 is 3. I will select minimum positive value from the theta column. Minimum positive value from the theta column. So this is my entering row. This is the pivotal value. Pivotal value. So what is my decision? A1 will leave the basis. A1 will leave the basis in place of that x1 will enter. So in the first iteration itself, artificial variable is leaving. So the next iteration onwards, don't make this column. Don't make this column. Make table 2. I'm giving you 30 seconds break time little bit. So that now third table, make these values 0. It's already R1 new is nothing but R1 old minus 2 R3 new. R2 new is nothing but R2 old minus 3. So giving you 1 minute break time, you make a new matrix quickly. See, the only benefit of recording is in the calculation whenever you are lacking, you can pause the video, and whenever you reached that point, again you continue. So this is one of the advantage I see for the recorded ones. Okay, you make the table 2 completely. Make table 2 completely. I will not make the artificial ones. I will not make the artificial column. So final matrix I am giving you here. Because with the help of this problem, I want to teach you one very beautiful concept. With the help of this problem, I want to teach you a very beautiful concept. Zero, 0, 6. EJ minus EJ also we can write it down. 0, 2 minus 6. So the maximum negative is here. This is the entering column. Some students say, and here 2-3 important things I want to teach you with the help of this question. With the help of this question, I want to teach you 2-3 very, very important questions. Okay. Some is, sir, this slack and surplus variables we cannot take decision on that. No, it is not correct. Slack or surplus variables also may interchange and keep on going and coming and leaving the basis. So it's a correct decision. Now theta 24 divided by 2 is 12. 15 divided by 3 is minus 3. From here we select the minimum positive. This is the pivotal value. So our decision is, because this is the entering row, na? Decision is S2 leaves the basis, and in place of that, in place of that, S3 appears. In place of that, S3 appears. This is the pivotal value for this iteration. How to make the pivotal value 1? Divide by 3. Make this value 0 and this value 0. So how to do it? R1 new will be R1 old minus 2 R2 new. How to make this 0? R3 new is nothing but R3 old plus R2 new. This will be 1. This is minus 1 already, na? So when you do these operations, you will get a new table. Again, I am pausing for 1 minute. Can you make a new table? Please make the new table. Please make the new table. Please make the new table. So I am making the final table 3 for all of you. Final table I am making for all of you so that you can match. And finally, 𝐸𝐴 minus 𝐸𝐴. Zero, 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 2, 0. This should be the final table. Once again, the way you should do all these things is, you make the video pause for some time, and then again continue when you reach to that particular level. So this facility is there with you, because I am sure when I am teaching Simplex in the live classes, it will take minimum 8 hours or 9 hours minimum. It's a long topic, because I give time students to solve. If there is a doubt, I clarify. Live classes are just like offline classes, okay? Very, very important concept here. Very, very important concept here. Just relax, take little water, relax, and see what I'm doing here. All the values in 𝐸𝐽 minus 𝐸0 are positive. So it's an optimum matrix. So the solution is x1 is equals to 8, x2 is equals to 0, because x2 is not in the basis, so that is 0. Correct, na? So solution and the maximum Z is nothing but 8 into 6 plus 4 into 0. Correct, na? That's what we will do and get away with it. But if you can recall, this problem in graphical, same thing we have done in graphical. Same problem we have done with the graphical method. So what was our this was the feasible region. Correct, na? Same problem we have done and we have elaborated there. So at the farthest point, objective function line is superimposing over the constraint. Superimposing over the constant because the slope is minus 3 by 2. Here the slope is also minus 3 by 2. Slope is same. So all the points falling on this line will give me the optimum point. So you can say this problem is having alternate solution. Or you can say infinite solution. In graphical, if you know these 2 points, this point and this point, if you know these 2 points, you can calculate infinite solutions. This I have taught you in graphical method. How to calculate infinite points, I have taught you in the graphical method. But my basic question comes, it's a very, very important point for all of you. Very, very important point. In the simplex, how will I identify? In the simplex, how will I identify? In the simplex, how will I identify? By looking at the final matrix that there are alternate solutions. How will I identify looking at the final matrix that there are alternate solutions? Like this one. This is the final matrix. By looking at the final matrix, is it possible to identify that there are alternate solutions? See, simplex is just an extension to graphical. Whatever graphical is teaching, simplex is also teaching the same thing, na? Simplex is also teaching the same thing. Now comes the punch key. In the final matrix, in the optimum matrix, whatever variables present in the basis, in the optimum matrix, whatever variable are present in the basis are called basic variables, are called basic variable. So what are the basic variables? S1, S3 and X1. S1, S3, X1 are the basic variables, correct na? Now remaining variables of the objective function, remaining variables of the objective function that are not in the basis are called non-basic variable. Non-basic variable. Basic variable understood na? Now the remaining variables of the objective function that are not in the basis are called non-basic variables. For example, S2. S2 is not present here, na? X2 is not present. So S2 and X2 are non-basic variable. S1, S3 and X1 are basic variables. Basic variables and non-basic variables. Okay, na? This is clear? Now, during our practice, we have constructed multiple simplex tables. We have constructed multiple simplex tables. And each and every simplex table you must have seen that in 𝐂𝐸 minus 𝐂0 there will be 0 below each basic variable. S1 is a basic variable, S3 is a basic variable, and X1 is a basic variable. Because these variables are present in the basis, so X1, S1 and S3 are the basic variables. So below X1, 0, below S1, 0, below S3, 0. It will always happen. It will always happen that below a basic variable, it will always happen that below a basic variable in the 𝐂𝐸 minus 𝐂0, there will be 0. If it doesn't happen, it means your calculation is wrong. If it doesn't happen, it means your calculation is wrong. Okay? Suppose if it so happens that there is a 0 below a non-basic variable. If it so happens that there is 0 below a non-basic variable, in the optimum matrix, if it so happens that below a non-basic variable there is 0, it means there are alternate solutions. It means there are alternate solutions. If it happens that below a non-basic variable there is 0, it means there are alternate solutions. That is an indication. Now, now, how to find out the alternate solution? How to find out the alternate solution? Select that 0. Select that column. And do exactly the same procedure. Calculate theta minimum. Do exactly the same procedure. If you do it, you will get the second point. This problem we have done in graphical. So if you do this procedure, you will get the second point. So it was a very important concept that we are discussing last 5 to 10 minutes. How to identify and how to calculate the alternate solutions in any simplex. In any simplex procedures. Okay? See the next question. Maximum z is equals to 2x1 plus x2 subjected to 4x1 plus 3x2 less than equal to 12, 4x1 plus x2 less than equal to 8, 4x1 minus x2 less than equal to 8, x1 x2 greater than equal to 0. It's another very beautiful problem. Another very beautiful problem. Okay. So I will not go to the nitty-gritty details that every time I'm doing. Directly I will say S1, S2, S3, all slack variables. Let us make the table. Because here I want to teach you very important concept here. That is the reason I'm taking up this problem. So x1, x2, s1, s2, s3, and then b. First 4, 3, 1, 0, 0, 12, 4, 1, 0, 1, 0, 8, 4 minus 1, 0, 0, 1, 8, and the basis will be S1, S2, S3, 2, 1, 0, 0, 0. That's the way we do it. Okay. Let us solve it, then we will come to know what the problem we will face. 0, 0, 0, ej, 0, 0, 0, 0, 0, ej minus ej, minus 2, minus 1, 0, 0, 0. We take the maximum negative, entering column. Calculate theta. 12 divided by 4 is 3. 8 divided by 4 is 2. 8 divided by 4 is 2. We select the minimum positive from the theta. Select the minimum positive. The problem is there are two minimum positive same value 2, 2. Now what you will select? This 2 and this 2. What you will do? So simplex procedures in which you are not able to decide the entering row. This is called degenerated solution. Degenerated problem. It is called degeneracy. Degeneracy in simplex. It is called degeneracy in simplex. Correct or not? Degeneracy in simplex. Now, how to solve the degenerated problems? If the problem is a degenerate, my tie is between second row and the third row. My tie is between second row and third row. Then what we will do? We take the decision on minimum of Si over Xi. For whatever parameter it is minimum, I take decision on that. What is Si or Xi? These ones. If the problem is degenerated, I will not focus on x1, x2. I will focus on slack or surplus variable. That to second or third row. Si by xi means first I will take this column. Si means S1. When no decision is taken on S1, I will go to S2. When the no decision is taken on S2, I will go to S3. That way I will do. Okay, na? So Si over Xi, because Xi is the entering column. So minimum of, see what I am doing, this divided by this, or this divided by this. Oh, both are same. So decision cannot be taken based on the first iteration. Go to the second one. Go to the second one. This divided by entering column. So I have to select the minimum of 1 divided by 4 and 0 divided by 4. So minimum is 0. And 0 appears for this value. So third row will enter. That is the way we select entering row. In the degeneracy problem, this is the procedure to select the entering row. You have to be very, very careful. Simplex is, very beautiful. How to select the entering column is easy, but how to select the entering row, we have to do some iterations. Now let us diverge a little bit. There is something called duality. Once again, this is one-shot crash series. As I told you, that normally if I accelerate simplex, it will take 8 to 10 hours for me to complete syllabus. But here I want to introduce each and everything, at least introduce each and everything. Regular course, we will teach everything, don't worry. So, for every simplex problem, there will be a dual. there exists another linear programming problem that gives exactly the same solution. For every primal simplex problem, there exists a dual problem, another linear programming problem that will give you the same solution. Now, sometimes this question may come to your mind that what is the need of dual? Look at this problem. Minimization function. There are 4 constraints, and each constraint is having greater than sign. So each constraint will have one surplus variable and one artificial variable. So imagine the objective function will have how many variables? 3 normal variable, 4 surplus variables, and 4 artificial variables. So objective function will have 11 variables. Alright, there is a limit, na? There is a limit to do anything. So that is the reason there is a dual. To convert the problem in dual, these signs should be same. Either greater than sign or less than sign. These signs should be same. Either greater than sign or less than sign. Suppose one sign is less than equality, and I have to convert into dual. You know what I will do? Multiply the entire thing by negative. This negative, this negative. If I do that, the sign will change. For example, minus x1 minus 2x2 minus 4x3 less than equal to minus 50. If you put negative sign everywhere, the sign will change. So before converting any primal problem into a dual, these signs should be same. Now, we should learn how to write the primal problem in matrix form. So I am writing the matrix form. Minimum z is equals to 5 to 1, x1, x2, x3. This matrix form 2, 3, 1, 6, 8, 5, 7, 1, 3, 1, 2, 4, x1, x2, x3, the same sign 20, 30, 40, 50. This is a primal problem, okay na? Now I am converting the primal problem into a dual problem. Whatever solution primal problem is giving you, dual will also give exactly the same solution. Dual will also give exactly the same solution. So how to convert it to dual? Everything becomes reverse. So look at carefully, everything becomes reverse. Minimum becomes maximum. This matrix will come here. This matrix will come here. This matrix will come here. 20, 30. Number of variables in the dual changes. Number of variables in the dual changes. Number of variables in dual will be equal to number of constraints, let us say y1, y2, y3 and y4. So number of variables in the dual becomes equal to the number of constraints. This matrix will become transpose. This matrix will become transpose. So 2, 6, 7, 1, 3, 8, 1, 2, 1, 5, 3, 4. Transpose, na? And of course the variables will be those variables y1, y2, y3, y4. This sign changes. Everything becomes upside down. This sign changes and this matrix will come in the transpose form here, 5, 2, 1. This is your dual problem. Whether you solve this or this, answer will come out to be same. This problem, if I write in this form, it will be maximum z is equals to 20y1 plus 30y2 plus 40y3 plus 50y4 subjected to 2y1 plus 6y2 plus 7y3 plus y4 less than equal to 5, 3y1 plus 8y2 plus y3 plus 2y4 less than equal to 2, y1 plus 5y2 plus 3y3 plus 4y4 less than equal to 1. So only 3 constraints. And only the slack variables will come. So number of variables here, 4 plus 3 slack variable, only 7. Previously there were 11 variables. Now same simplex problems can be solved only by 7 variables. Okay, na? Dual of dual will again be primal. Suppose if you see the dual of this problem, again the primal solution will come. Dual of dual is again a primal solution. Understood? Don't think that these problems do not appear in GATE. Or a GATE very beautiful problem appears. Okay, na? Because next I am going to cover one PYQ to make you confidence, because sometimes teacher may bluff that actually whatever he knows he is teaching, and he will say this is not in syllabus, this is not in syllabus. Some people say this is not in syllabus. So for that reason I have taken one PYQ, very beautiful PYQ. This is a GATE 2011 problem. Of course there are many problems based on simplex, but this problem is a unique problem, GATE 2011. Because some of you may be wondering, what are these variables y1, y2, y3, y4? New variable, what are these variables all about? Correct? You may be wondering. To explain that, I have taken one PYQ. This is your GATE 2011 problem. GATE 2011 problem. In the exam, only the text was given to you. Only the text was given to you. I have made this table for all of you. Problem is, you can see yourself in P by Q. It's a GATE 2011 problem. There are two resources, resource R1 and resource R2. And maximum capacity available for resource R1 is 90 kg. Maximum capacity of resource R2 is 100 kg. P1 requires 3 kg of resource R1 and 1 kg of resource R2. Product P2 requires 2 kg of resource R1 and 2 kg of resource R2. Product P1 gives you a profit of 2000 rupees per piece profit, and P2 gives you 3000 of rupees of profit. Okay, na? So, of course, it was a 4 marks problem, linked problem. First question was easy. What is the maximum profit? And we have already solved in graphical and simplex many such problems. So I'm not going to go elaborate too much on that. Second part of the problem is, what is the dwell price of resource R2? Dwell price of resource R2. If you see the solution by anybody, it's a very vague solution. No stuff. What is the dwell price? First of all, people should explain what is the dwell price, na? So let us say I want to produce X quantity of product P1 and Y quantity of product P2. So maximum profit should be equal to 2000x plus 3000y, correct, na? Subjected to constraints, 3x plus 2y should be less than equal to 90, correct? And x plus 2y should be less than equal to 100, and x and y should be greater than equal to 0, because it should be a realistic figure. It should be a realistic figure, correct, na? Now this one, I will explain to you what is the dwell price, okay, na? I will explain to you what is the dwell price. But first of all, let us convert this into a dwell problem. Okay. What is X? Quantity. X and Y are the quantities of number of product P1 and product P2. It's a number, na? And objective function is in the form of rupees. Rupees. Is that okay? Now I want to convert this into a matrix form first. Maximum Z is 2000, 3000. Of course, answer I can give you in 1 minute, but you should understand, not suppose some related problem comes, how will you handle? Okay. Then constraints are, sign is same, 3 2 1 2, 3 2 1 2, x y less than equal to 90 and 100. See, this is the thing. This is the primal. Okay, all right, everybody's okay. Now, the dual. Everything will become reverse. Maximum will become minimum, Z. This will appear in here. 90, 100. Variables will be, let us say, y1, y2. Okay, na? I will tell you what is y1, y2. Transpose of this 3, 1, 2, 2. Y1, y2 greater than equal to 2000 and 3000. This is the dual problem. Value of x, y, whatever primal is giving, will be different than y1, y2. Objective function will be same, dual, but the y1, y2 and x1, x, y are different. So this is minimum z is equals to 90 y1 plus 100 y2 subjected to 3y1 plus y2 greater than equal to 2000, 2y1 plus 2y2 greater than equal to 3000. Now see, I think some of you, maybe studying this thing first time. No problem. For doubts, our team is there. Don't worry. Okay, na? As I told you, for taking care of material science, production, industrial, we have 3 faculties. Okay, na? Depends upon who is available. He takes care of the classes. So everybody can answer questions. Okay, na? In the primal, this is the cost, na? Or you can say, better to say, price. And this is quantity. Correct, na? Quantity. Now in the dual, quantity came to the objective function. Because quantity went there, na? Price came here. Price came here. This y1 is related to resource 1 and y2 is related to resource 2. So see here, it is asking y1, because the price came in the constant, na? Y1 is the called 12 price of resource R1. Y2 is the 12 price of resource R2. All right. Now you can solve it by graphical method. Graphical method will be easier here. So y1, y2, first constant, second constant. So y1 divided by 2000 by 3 plus y2 divided by 2000 greater than or equal to 1. Okay. Okay. Two 2000 by 3. 2000. Region will be away from the origin. Okay, na? Second constant, y1 divided by 1500 plus y2 divided by 1500 greater than or equal to 1. So 1500, 1500 constant 2. So you know what is our feasible region? This is our feasible region, okay na? That's our feasible region. Now what is the optimum point? Let us go by the slope method. The slope here is minus 9 by 10. Slope here is minus 3. Slope here is minus 1. Okay. So my objective function slope is less than 1. So optimum point will be minus 0.9 here, na? My optimum point will be intersection of x-axis and constant 2. X-axis and constant 2. In a graphical, we have already done this thing. So this is my optimum point. 1500 and 0. So dual price of resource R2 is 0. Dual price of resource R1 is 1500. Dual price of resource R1, suppose they ask you, because if you see the solution of any coaching institute, because you know, last 23 years I'm teaching all these things. Any coaching institute you see, there some vague kind of description is given. You just check it if you don't believe. If the question is asked dual price of resource R1, then you will be goal. So you should understand what is the dual price. So the answer here will be 0. Okay. Now, before closing Simplex discussion, I want to introduce sensitivity. Before closing this discussion, I want to introduce sensitivity. So this sensitivity discussions may be helpful to you, for especially for GATE, to handle some theoretical questions. This is my problem. Maximum z is 3x1 plus 2x2, and there are 4 constraints. And this is the optimum table. This is your optimum table. Just I am giving a little glance, and then we will close Simplex. Because in one shot crash series, our goal is to not have very long classes, and everything is packed. And if there is any doubt, we are there. This is the solution. In the final matrix, if you remove x1, x2, because x1, x2s are present in the original objective function, after x1, x2, whatever is there, let us say this is matrix A. Remove x1, x2 because x1, x2s are there in the original objective function. So after that, whatever is there below slack or surplus variable, let us say that is matrix A. Okay. On the right hand side of the constant, that is a matrix B. That is matrix B. If you do A matrix into B matrix, Below this B, this matrix is called small b matrix. Small b matrix. This matrix into this matrix, you will get answer small b matrix. This into this, meaning 1 into 6 minus 1 by 2 into 8 plus 0 into 1 minus 1 by 2 into 2. So 6 minus 4 minus 1 is equals to 1. Na? See, 1. If that comes, it means your solution is correct. Matrix A multiplied by whatever is there on the right hand side of constant, that matrix B will be equal to this small b matrix. You know, I've just give 1 or 2 sentences and then close the session. In engineering service, previously engineering services, now engineering services, and upcoming IRMS, IFS. In these, a typical type of question appears that in the object constraint, let us say in place of 6 there is a 7. Without going through the whole procedure, what is the final solution? Now these tricks will come. These tricks will be used to handle the solution. So these things we will cover whenever we come up with that that particular program for all of you. So in approximately this 3 hours lecture, we have tried to summarize the simplex method primarily for gate and other objective examinations, but for conventional, some more detail has to be taught. And my next lecture on the one shot will be on transportation. Thank you very much.